Go ahead.
So my group, we were working on using artificial neural networks for financial modeling. So we worked specifically with the Black-Scholes model. And so the Black-Scholes model is a differential equation used to price options and takes into account strike price of an option, current price of the stock, time to expiration, risk-free rate, and volatility. So when people do this, you have to use certain assumptions, and these assumptions, like using risk-free rate and volatility, can cause the Black-Scholes model to deviate from actual market value. And this makes it a prime candidate for using machine learning because you're able to use large data models and try to use these different neural networks to minimize these assumptions. And so the goal of the project was to minimize these errors with the Black-Scholes model. So we employed various machine learning models to ascertain which ones predicted the price of the options most accurately. And we subsequently analyzed the results of the various models to assess their accuracy and understand the reasons for their success or failure. So one of the big things we did was look at the different models that we had and the different moneyness values, and saw where they perform better in certain cases or not. And so something that I realized was that, like, our MLP model would perform, drawing a blank off the top of my head what side was which, but either very well or very poorly, depending on if it was a linear or nonlinear data. And so I used leaky ReLU, which is a rectified linear unit, and parametric ReLU. And so this is basically an activation function for MLP, which sets the data that's near zero to a certain slope, which prevents the nodes from just infinitely sending out zero. And leaky ReLU is normally less accurate because that predetermined slope was just an arbitrary number that I set close to zero. And parametric ReLU is normally better when you have big data sets and just a lot of time and a very strong computer. And I was actually really surprised that leaky ReLU was outperformed ReLU in this case, parametric ReLU. So my involvement was I joined the semester. So since joining the team, I met weekly with the group I was on, and we presented our progress to Hariam. So I wrote a research proposal to Lehigh's research computing and gained access to the Hawk and Soul cluster, which I feel like not only helps our team, but also any of the projects in the future. We now have access to this, so we're able to run bigger models and take on more technical problems. And so I also worked independently with Ryan Bradley, who's in charge of the research computing here. And so we developed a conda environment, which is basically just all the dependencies that your program needs. And lots of the time, different dependencies like NumPy or TensorFlow, they don't necessarily work best with each other, just certain versions. And some things get outdated. So just coming up with an environment that will suit our team and eliminating the need for everyone else to learn how dependencies work. So we just got that done on the side so we could help everyone else. And so I worked alongside with Yannick to just develop all of our heat maps in the beginning and kind of help with the programming on that end. And that was something that we really were presenting to Hariam a lot. And like I mentioned earlier, I came up with the different activation functions that we ended up using. So things I learned during the project was, for the research computing, they use something called Slurm, which is just a workload manager. And this is extremely helpful because if you go to a company like Citadel or Renaissance or any of these big funds, they're going to have their super strong computers that they do a lot of their training on, and you can't run everything at once. So these workload managers will figure out what to run and when. And it's just a very unique niche thing that having that exposure to, I feel like, really helps stand out against other people who've never used it before. So going into the project, I was familiar with like what the Black-Scholes model was, but I'd never really gone into like a deep dive. And so like it introduced me to Ida Lamma, and just all of stochastic calculus in general. And I'm something that I'm probably going to self-study on my own time, just because I know it's extremely important for quantitative finance, and I feel like it will definitely give me an edge. So just further research. Even though I came in with a strong coding background, just because I'm a CS major, my machine learning knowledge is definitely lacking. And just working on this project, it's gave me a lot of exposure to it, and something that I realized I really enjoy. And so to address this, I plan on taking CSE 326, which is a course focused on machine learning. And I also learned, this is the first time that like I ever just joined a project and was like given a textbook or given resources and was told, learn everything you can. I think I finished Harriam's book in maybe a day and a half. So I'm also going to be joining Professor Carr and Professor G's research on predictor corrector methods for multi-objective optimization of fair machine learning. So I feel like just having more machine learning research will definitely help not just myself, but the quality of our projects in the future as I become more familiar with that stuff. And I feel like this will be extremely helpful because Carr has her PhD in applied linear algebra, I believe. And so just getting a more technical math aspect, and Professor G's produces majority of Lehigh's machine learning research. So just learning from him will also be really helpful. So I'm also currently interviewing for quantitative research internships at banks and hedge funds, and plan on doing this type of research after graduation. I'm almost done in getting a UBS quantitative research internship. So any suggestions for studying for the final phase, I'll definitely take. And for future work, this summer, I plan to continue my work with this project as we write a research paper for publication. And I feel like this being published is just going to help not just the team, but also it's always good for Lehigh to have their name in anything published.
I think it would be great because we had another paper written on, this is project number 11, on project number 7. I don't know if you probably looked at it as well with the Brian Yukelshik.
Yeah, I think they're using that as a template. Almost.
Correct. And I think that Ariam and I tried. I mean, the goal is let's publish something, let's say something. And I think with your work, I think we should be able to achieve that. So that was a great job.